Okay, welcome back. Well, welcome back if you've been here before. If not, hello for the first time. What we're going to be doing today is going over the Gemini 1 from 1965, the G-12, the Ampeg. I said that all backwards, didn't I? It's an Ampeg Gemini 1 G-12 from 1965. All right, I've done some stuff here. Actually, yesterday I did a full video installing the cap can and the dual filter cap, and it turned into a huge debacle. I'm actually going to post it at some point. I got to put something together. It's going to end up being a blooper reel, but in that there's some important information and thoughts about installing the cap cans and the differences between the original Mallory's, I believe, and the new CE, which are supposedly built on the same. This is not the one that won an amp. This is obviously another one that are built on the same equipment. They say it's the same specs. There's little differences between them. So once I get that on there, you may want to take a look at that to see the difference or what's important there. So today, everything is installed. All the caps are done. Everything's cleaned up. And I'm going to start it up for the first time. No tubes, there's going to be no load. What I'm looking for mainly today is to make sure that I'm getting appropriate voltages. I am not going to turn this all the way up. I'm going to use my variac. I am going to use a current limiter. There should be absolutely no current going through this amp because there's no tubes in it. If that lights at all, then I've got a problem. I've got a short somewhere, probably in a transformer or elsewhere, that's actually causing current to be drawn. So what I'm looking for here is that I've got seemingly correct-ish voltages. They're not going to be loaded, so they won't drop from each node. They'll basically stay at one level. So that's important to realize, is because if you drive this to full house voltage, the primary, your secondary down the line is going to be too high potentially for the lower spec caps that are usually down the line in the B plus rail. In other words, the ones that are getting closer to the preamp, a lot of times you'll see the voltage specs will drop on those because the voltages have been knocked down in order. You may have only 250 volts at that last node, so a 350 volt cap may be aces. But at the primary, at the first node in the secondary, off of the filter cap, that voltage may be well over 400 volts. And so if you show 400 volts at that 350 volt cap down the line with no load, it could be a problem for that cap. Anyway, so let's get this started up. I happen to know my variac where 50% is. I have it actually marked there. It'll be close enough to 50% of my house voltage, and I'm not going by the number that's on there, I'm going by testing it. So it'll be about 60 volts. I can test it again, but that'll be close enough. I'm looking for, probably most importantly, I want to see what the filament voltages are going to be, because that's going to be the real tricky part of the amp. Being an older amp, 1965, the wall voltages were lower. So the primary side of the amp is looking maybe for 115 volts. You put 120 or sometimes even more, you start pushing the voltages on the secondary too high. And the most susceptible place is actually the filament, because it's much more difficult. If it's on, let me step back. If the voltages on the first nodes of the secondary for the B plus rail go high, there's ways to address that. There's easy ways, you want to call it that, to knock down those voltages if you want to. Or for that matter, leave the voltages higher if the tubes can handle those voltages and rebias accordingly. However, on the filters, on the filaments, when the voltages are too high, it can be a real struggle to try to knock them down. There's a high current. I've done it in amps before. I had a Harmony, an H415, 415, it's the one with the 212s, that I installed 10 watt, had to spec out what the voltage drop I wanted. It was running over about 7 volts on the filaments. I wanted to knock it down closer to 6.5 or lower, and I had to calculate out for each side 10 watt, I don't have them here, they're actually in the back, 10 watt wire round resistors that are about 0.12 ohms each. And obviously with 10 watt resistors, where do you put those if you need that? Okay, so that's what I'm really more interested in checking out the filament voltage today. So that's what we're going to do. Let's spark it up. Let's turn that off. So I've got my variac on, my variable, it says variac transformer on it, by the way, which is kind of like saying a Kleenex tissue. All right, so let's see. This meter is set up to check my filaments. It's across one of the power tubes, pins 2, 7, and 2. Doesn't matter which side it's on because it's going to be on AC. Over here I've got my other meter set up to take a look at some of the DC voltages. I've got it connected to ground, and I want to see at various nodes what I'm getting at various points as I start up the variac. Also, this is a good way to start up. I bring it up to about 25% or so. And as we see, the voltage on the filaments comes up. That's great. And actually, even the light goes on. That's awesome, because these lights aren't easy to replace. I think there's a neon bulb in there. It's encapsulated in a housing. So that's a good sign. I like that. But let's think this through. If I'm at about, say, 25%, if I multiply that by 4, I'm talking about 7.2, 7.3 volts. Unloaded, once the tubes are in there, it'll drop down that voltage. But I'm not liking what I'm seeing so far. Let's just for fun see at 25% as this thing, as the new capacitors kind of form. They should be formed already. Let's see what I'm getting at my primary node, my first B plus node. I'm getting about 107 volts. I'm going to see 107 volts throughout pretty much all the other nodes because there's no load. So my second node, make a liar out of me. All right, 106, 107, I don't know why that is. And my last two nodes, B plus nodes, they may drop a little bit because there are some little bit of circuitry between there. So once again, I'm at about 25%. If that's 100, that means no load at about 100%. I should be seeing about 400 volts, the primary node. These caps, the rest of the caps should be able to take it if I went all the way up. But there's no reason to do that because I'm going to move it up to about, let's call it 50%. That's about 60 volts. All right. I'm liking that a little better. So easy math. At 60% of house primary voltages, I got about 60, 61 is my half. I've got about 121 or so volts in my house. At least today there was. And I'm getting about 3.4 volts across the filaments, unloaded. 6.8. The top you want is 6.9, and that's really pushing it. That's the upper limit of most tube spec filaments, 6.3 volt tubes, that is. So this is something that I'm glad to see because loading them with tubes, it's going to drop some. So maybe it'll be 6.5, 6.6. Certainly I'd rather it be colder, but certainly it's not going to worry me that it couldn't be plugged into just about any place, house power. I mean, unless you got some kind of ridiculously high voltage in your house, like 130 volts or something. Remember, you're talking about a multiple here. Each volt up in primary is several on, well, not several on 6.3, but anyway. Ignore that last comment. So let's see, just for fun, what we get at half should be around 200 volts. Yep. All right, I'm liking that. I'm gonna have to take a look at the schematic, which is under the tripod, to see what the voltages typically would be. I think they're saying, yeah, at the first node, this amp nominally, according to the schematic, should be about 360 volts. This is unloaded, it's going to be about 400. So it's going to be less than 400, so even if it's 370, 380, I think that's going to run this amp well. Obviously I will check the bias on the output tubes to see if any adjustment needs to be made on that cathode bias. So I'm liking it, and most importantly, the light went on at 50 50%. All right, just for fun, just going to check a couple of plates. Let's see, where's pin 1? All right. All right, we got a pin 1 there. Where's pin 6? This is actually, I think, the trem. Yeah, I mean, I'm getting the correct voltages across here. Looking good, pin 1. I mean, I should actually be testing at the tube itself, just to make sure that the socket is getting the voltage. That's important. I've seen that, I've done that before. I've checked on the board and they're like, oh, it's getting voltage. Why isn't it working? And then, well, there's a problem with the socket or the connection to the socket. So it's always best. So arguably, it's best to check from underneath into the tube socket itself, but I'm not going to do that. I'm going to trust that as I check here, 185, that's good. All right, just for kicks, let's see, making sure, another important test probably at this point is to check the plate. In other words, from this primary, this first B plus node here, this A node, if you call it A, that goes to the center tap of the output transformer primary. And those leads, it's a push-pull lead to, should be to the plate on these is 3. Let's see, where are we? Okay, here's 1. Yep, that's about right. It should be showing pretty much what I'm getting at the center tap, or slightly less maybe. There's no current being drawn once again, so it isn't like it really should show less. So that's good. I'm showing voltage at the plates. Let's, for fun, see the screens. These tubes have screens can be accessed through pin 8 or pin 4, and they're actually tied together on this amp. Not sure what the advantage of that is or not, but they're seeing voltage. All right, I'm liking it. High hopes here. We'll see what happens once I get tubes in. Ciao.